Hello students and welcome to lesson 9. So students, today we're going to be looking at solving simultaneous equations using elimination. This is one of the harder things we're going to have to do in Unit 1, but stay with me guys and you will get through it. So we're given two equations, 3x plus y equals 5, whoops, let's try that again, 3x plus y equals 5 and 4x take y equals 2. Note that we don't have a nice simple y equals statement that we can substitute in. What we're going to have to do here is eliminate. Note how we have a matching pair of y terms. We have a positive y and we have a negative y. So if I add these two together, they're going to eliminate. They're going to disappear. Think of it like if I went negative 1 plus 1, it's 0. If I eliminate these two y terms, all I'm going to be left with is x terms. So, as you can see I've written here, adding equations 1 and 2 will eliminate the y term. Again, like with last lesson, make sure you're writing down both equations, labeling one as equation 1, the other as equation 2. So students, I've set this one out a little differently, and this is how I would recommend setting it out. I've written equation 1 here, equation 2 here, and then, like when you were in primary school, I've put a big plus sign here, and then I've worked through it. 5 plus 2 is 7. Y plus negative y eliminates, so I'm not going to write anything there. 3x plus 4x gives me 7x. Then I rewrote the statement here. 7x equals 7, as you can see. So if 7x equals 7, well, all I need to do is move the 7 over here, as you can see I've done there. X is equal to 7 divided by 7, so x is equal to 1. But, of course, I'm not done. Now that I know what x is, I now need to substitute x equals 1 into an equation. I've chosen equation 1. I could have gone equation 2, but I thought, well, look, 50-50, let's go with equation 1. It doesn't matter which one you substitute it into, but I would recommend going with whichever one looks like it's easier to work with. So, equation 1 was 3x plus y equals 5. As you can see, I've replaced the letter x with the number 1 here, giving me 3 times 1 plus y equals 5. This simplifies to 3 plus y equals 5. I move the 3 over here, so y is equal to 5 take 3, so y is equal to 2. Like with our lessons from last week, students, oh sorry, not last week, like with our examples from last lesson, we need a statement at the bottom here explaining what both coordinates equal. Therefore, the solution is x equals 1, y equals 2. Okay, on to the next example. We have two new equations. 2a plus b equals 7 and a plus b equals 5. Like always, I've written both equations here and labelled them 1 and 2. Now, in question 1, or rather, in the first example, you saw I had an alternate pair, a positive y and a negative y. Can we all see, in the second one, it's not quite like that. We do have two b terms, but one's positive and the other one is positive. So I need a b term to be negative. I need one of these b terms to be negative in order to eliminate. So what I'm going to do is I'm going to multiply all of the terms in equation 2 by negative 1. If I negativize equation 1 up here, equation 2, if I negativize equation 2 up here, I'm going to have a positive b and a negative b. So, of course, what I do to one thing in an equation, I have to do to the rest of it. So here's equation 2. I'm multiplying everything in this equation by negative 1. So negative 1 times a gives me negative a. Negative 1 times b gives me negative b. Negative 1 times 5 gives me negative 5. So it's negative a plus negative b. But that's not really the best way to write it. We would write it as negative a take b. Now I have a third equation. See how I've labelled it equation 3. Equation 3 is negative a take b equals negative 5. So if I add together 1 and 3, it's going to eliminate b. Sorry students, the mower is just going past right now. Okay, he's nearly done. All right, no, yeah, he's gone. Maybe you guys didn't even hear that, but I could hear it and it was bothering me. Anyway, so students, if I add together equation 1 and equation 3, that will eliminate the b term. Because equation 3 has a negative b, equation 1 has a positive b. So, like with before, I've written both equations. 2a plus b equals 7, and negative a, take b equals negative 5, and I'm adding them together. 7 plus negative 5 is 2. b plus negative b eliminates. 2a plus negative a, well that's the same as subtracting a, so it gives me just a. So a is equal to 2. But of course I don't just want a, I also need to figure out b. So I'm going to substitute a equals 2 into equation 2. Why did I choose equation 2? Well, of the two of them, equation 2 looks a little bit easier to work with, don't you think? Yeah, that's why I went equation 2. You could certainly substitute a into equation 1 up here. Anyway, so I'm going to sub a equals 2 into equation 2. Here's equation 2, a plus b equals 5. So I've replaced the letter a with the number 2. 2 plus b equals 5. I move the 2 to the other side by subtracting. B is now equal to 3. So, final statement of course, a equals 2, b equals 3. So, students, have a crack at the first round of questions on the OneNote. Then I'll be back later for a few more examples.